All right. So today we're going to talk about complex numbers and imaginary numbers. We've all done square roots before, right? We know the square root of 4 is 2. 2 times 2 is 4. But what we've learned up until this point, well, for those of you that haven't had this class yet, is that when we take the square root of a negative number, it's typically no solution because two negative numbers multiply to a positive, and of course, two positive numbers multiply to a positive. So we typically don't have any solution to the square root of a negative number. But in mathematics, they introduced the concept of an imaginary number, which defines the square root of negative 1 to be I. So the square root of negative 1 is going to be defined to be I. And from this, it creates a whole new world of numbers. Now, just to give you an idea, if we do the square root of negative 4, well, the square root of 4 is 2. And then since there's a negative inside the square root, we add the I, should be 2I. Square root of negative 9, well, the square root of 9 is 3. Because we have the negative inside of there, it's going to make that 3I. Square root of negative 36 is 6. But because we have the negative inside of there, it's going to make that 6I. So that's how we get these i's, and these are all considered imaginary numbers. So if we go to the number systems and we look at the different types of numbers that we have, we've got real numbers, and then we've got imaginary numbers, right? And the real numbers were numbers like fractions, integers, negative integers, decimals, even numbers like pi and the square root of 2 are all real numbers. The imaginary numbers are going to have the i's when you get a negative inside of the square root. So let's kind of continue on with this idea. The square root of negative 13, well, we don't know what the square root of 13 is, so we're just going to leave it as the square root of 13. But we're going to put the I off in the corner then. And that's typically how we write an I when we have it with a root, is we just put it in the corner. So we have I root 13, which is the same as the square root of negative 13. Now this one, when we do that, we put the I in the corner, and we get I square root 50. But we can simplify the square root of 50, right? There's a perfect square that goes in there. We go through our list of perfect squares again. 4, 9, 16. And then we get the one that's the biggest perfect square, which is 25. So this right here is going to equal I times 25 times 2. Make that an I there. All right, so then when we simplify it, we get I times the square root of 25 times the square root of 2. And the square root of 25 is just 5. So this just becomes 5I square root 2, which is how we would write the square root of negative 50. So a complex number is going to be when you put a real number and an imaginary number together. So it's A plus BI. The A is the real number component. The BI is the imaginary component. We call that a complex number. We can graph complex numbers. When we do so, our typical x-axis is going to represent the real number. Our typical y-axis is going to represent our imaginary number. So like if I want to graph 2 plus